Hey everybody. Today we are going to talk about quadratic formula, and if you want to think about it as day 2, then today is day 2. I'm assuming that us coming into today is very comfortable working through with quadratic formula, and we're frankly really comfortable solving any quadratic equation thrown at us. What I want to focus in on today is what you see in green. It's something called the discriminant, and we're going to talk about that in detail today. So you may look back on today's lesson and really kind of say, hey, that was the focus of today, which it is. But really, we're talking about quadratic formula, and with a bigger umbrella, we're just talking about solving quadratic equations. So let's jump in and see where we're at. What you see on the screen right now is a very usual instruction. You can see that we are to solve. And what I've done is I've thrown a doozy at you. I think that this would probably fall into the category of like the most difficult quadratic equation you would be asked to solve. So with that in mind, I think if you're able to solve this quadratic equation, you are good. And that is a great gauge for you that you are ready and you are comfortable with everything you should be, up to like the most difficult level. If we struggle with this problem, then we have to keep in mind that doesn't mean that I stink at solving quadratic equations. No, what it might just mean is we're having difficulty with the ugliest one. And so then we keep working on our practice to get more and more comfortable. Okay, so I have given this one to you. What I want you to do is I want you to solve it on your own so that we get an accurate gauge of where we're at, some good feedback, and then we'll check back in and see how things go. Okay, pause the video now. Okay, we're back. I am just going to shrink that down a little bit to make a little more room because we might have a pretty lengthy solution here. I am hoping that when you take a peek at that, we recognize we want to isolate our variable. So in order to do that, I think expanding brackets and collecting like terms is going to help. So perhaps you give me this line, leave the 4 out in front, expand that perfect square binomial, and then maybe do the same, leave the 2 out in front. Hopefully we didn't fall trap to that bedmass trap right there of trying to take the 8 minus the 2. And now expand those two binomials. I'm going to get a 14 and a negative 3, so that is a positive 11 x's. I think that that would be a very common first step. Some people are going to feel comfortable to expand that perfect square and multiply in the 4 all in one go. If you are, then maybe we're comfortable to just simplify the whole left side. Same thing on the right. I think we're not as comfortable, but maybe. So maybe what we can do is leave the 8 out in front, expand in that negative 2. But now when I go to expand the negative 2 times the negative 21, that's going to give me a positive 42. Now I collect it with the 8, and maybe I come in there. At some point, I think we should have that gold line in our solution where we have each side simplified. Okay, now we're looking to solve that, so we're looking to collect all of our variables. I notice that if I put everything on the left side, I'm going to have a positive leading coefficient. So hopefully we are focusing in on that red arrow and saying I would get an 8x squared on the left. If I look at the right side, I have to get rid of a minus 22, which means I'm going to add my 22x. That's going to give me a negative 18x. I then have to get rid of a plus 50, so I'm going to minus 50. And hopefully we came in on that in standard form. Now we take a peek and we notice, hey, I've got a common factor of at least 2 in everything. And so we should be motivated to divide out that common factor of 2 to shrink everything down as best as possible. Okay, that should be the version of our quadratic equation that we are looking to solve. Okay, pretty quick. I should be checking to see if it factors. I can very quickly know that I cannot use 2 and 2 in my fast factoring chart. because I have an odd number in the middle, and anytime I multiply by even numbers, they create evens. So I am totally going to skip even trying a 2 and a 2, and I know if it does factor, it's got to be 4 and 1. Okay, I'm trying to get a 9 in the middle. Like if I go 9 and 3 for my 27, that's a 12 and a 9. That doesn't work. That's 36 and 3. That's getting me farther away. 27 and 1 isn't going to... Okay, so I need to use quadratic formula. We should be very, very comfortable with quadratic formula up to this point. But maybe we're trying to drill it in, and so we're going to keep writing it out and writing in the formula until it is automatic and you don't even have to think about it. There's my green for my quadratic formula. Oh my goodness, I got to shrink this down again. And then my line that I suggested to you was sub everything in and simplify each term. Okay, well, we got a little bit of work to do on this last term. I need to take a negative 4 times a 4, so that's going to give me 16, times a positive 27. So I see that I'm going to have my negative times a negative, times a positive. That's still going to give me a negative, and I get a whopping 432 all over 8. Okay, the nice part for us, though, I don't even need that therefore, is that when I do go through to simplify, I have to take 81 and subtract 432. I can see that I'm going to get a negative value underneath. Make sure you show your reader that negative value. And now when we see we cannot take the square root of that negative value, therefore, our solution, or this equation, has no solution. And there we go. Okay, I want you to take a look at that full solution because that was a biggie. The green lines I wouldn't have to see. I need to see the gold. And I would love it if we got down to the same thing as we worked our way through. We matched up and we were good. If you got down to what we did, same gold solution, then that is giving you great feedback. You are comfortable with solving quadratic equations, especially with quadratic formula. If you didn't match up, then we got to try to figure out, okay, was it a concept error? Those ones concern us, right? That means we're missing a piece of theory. Was it a silly mechanical mistake? That doesn't concern me. That's the sort of thing, they're annoying mistakes. I just got to try to work my way through. Okay, I want to take that solution and call that a representative solution of a quadratic equation. And what I want to do is I want to examine it a little closer. To do that, we got to zero in on something with quadratic formula. And here's the focus for today. I've just written at the top of the screen your quadratic formula in white. And I've asked a problem in gold. And this is not exactly an easy question to answer. And I think that I could probably ask this question to a number of people who are very, very comfortable solving quadratic equations. And I would get different answers. So don't hesitate if we don't match up. And this is going to be kind of an involved conversation. But when you read the gold problem or question, what part of the formula determines the number of solutions? So what part of that formula determines how many solutions we get? That's the question I want to answer. Because if we can zero in on that for today, that's going to help us to not just be good with solving using quadratic formula, but to really understand quadratic equations. And that's going to help us vault forward for our comfort level with where we go. Okay, so I want you to pause the video and take a moment to consider that gold question. It's not an easy one. It really isn't. Okay, pause the video now. Okay, we're back. So I'm going to shrink that down just so I can make some notes about some things. And I'm going to write over that quadratic formula a number of times. And I just want you to kind of zero in on why we could have some different answers. I'm going to try to guess at some of your answers you would give. So I would argue that the part of that formula that determines the number of solutions is the plus or the minus. Like, I'm going to argue it's the plus or the minus. Because right off the bat, the plus or the minus gives me up to 2 options. So I can get 2 options just because of that plus or minus. Now, if you look back at our problem for question 1, you'll notice the plus or minus, that didn't dictate anything. We had no solution to that equation. So I could see where some people would argue it's not the plus or the minus. But I think the plus or the minus is important. So I'm going to leave that circled in blue. I would have some other people that would say it's this whole square root thing. Like the square root thing is the thing that causes or determines the number of solutions. And I could see a valid argument for that, solely based on what we just talked about. Look, my solution to question 1, I got no solution to that because I had an ugly negative underneath my square root. Because I had that negative 351, well, then that's what dictates that I had no solution. So clearly it's the square root part. And that I don't necessarily agree with, but I can see the point. Okay, I'm going to go through and I'm just going to amend what I circled. So I'm going to erase that red. And I want to zero in on the red part. I'm going to call the red the square root. And then what I'm going to call the green is what's underneath the root. And I could hear a pretty valid argument for it was the green that actually causes your number of solutions. Like, because that green ended up giving us a negative value, that's why we had no solution. Had that green been positive, well, then we would have got 2 solutions. And so it's the green that determines that. I would probably argue that that is the view held by most. Okay, I want to nail down what we just talked about, but I want to talk about it in some detail. We're almost going to deal with it backwards. Because that b squared minus 4ac gave me different values. Like in example 1, it gave me a negative value. So I can just write that negative as a less than 0. That gave me no solution. And had that given me a positive value, then I would have got 2 answers. You probably came across in your practice last time that there's another option, not just 2 answers or no answers. Okay, it's the square root part. So I want to address the red. That because the b squared minus 4ac is under the root, that it's the root that determines the number of equations or solutions. Like if I take the square root of the negative answer, that's why. So it wasn't necessarily the b squared minus 4ac, it was really the root. And had I taken the square root of a positive number, so it's the root part. If the root wasn't there, well, then we could just calculate anything, positives or negatives. Okay, lastly, is it the plus and the minus? Like if that was only ever a plus, well, then we're going to get 1 answer. Or if it was only ever a minus, then we would get 1 answer. And it's the fact, if I write those a little closer together, that it is a plus or minus, that's why 2 options ever becomes a situation we deal with. Okay, there was a lot of stuff there. A lot of stuff in what we just talked about. What I want to focus in on is part of that. Really understanding, though, that the blue depends on the red. There's a relationship there. And the red depends on the green. There's a relationship there. That the green, the red, and the blue are all connected. And if we understand the relationship between all three parts, then we can draw conclusions. We can zero in on this green as an answer to our question. What part of the formula determines the number of solutions? Understanding that that green is affected by the root. And understanding that the root is affected by the plus or the minus. If we can see that holistically, then I think we're going to be comfortable. What I want to do now is zero in on the green, okay? So we're going to focus in on the part underneath the root. Here we go. Now, okay, so what you see, I've called it by its name, the green part. It is referred to as the discriminant. I've written it in blue off on the right. There's our part that shows up underneath the square root. There's our b squared minus 4ac. The reason why it can be referred to as the discriminant is because it discriminates on your quantity of answers, your number of answers. It tells apart whether there's two answers, a no answer, or one answer. What I want to do is I want to break down the discriminant, and I just want to focus in on that part. And in order to do that, we're going to talk about some terminology. But what we're going to do is we're going to do it within the framework of a little chart. So what I want to do is I want to build a chart. And what I want to do is examine probably the situation that is going to arise most often. The situation where we get two roots. Now, two roots is another way of just saying two solutions, two answers. When we solve a quadratic equation, it is very common for us to get two roots. Okay, how do we get two roots? Well, the only way that we can get two roots, okay, look up at my discriminant, is if I'm able to calculate the square root. If I can't calculate the square root, then I don't get any answers. So I have to be able to calculate it. Okay. I also have to be able to calculate a value that then I add and I subtract to give me two different answers. So my blue, my discriminant, has to give me a value so that when I take the square root of it, I can add it on, I can subtract it off, and it gives me two answers. The only way that that can happen is if my discriminant gives me a positive value. That's all. If when I calculate b squared minus 4ac, I get a positive value, then that's going to lead me to two solutions, two roots. Okay, let's jump all the way across. So I'm going to leave a column in the middle. And I'm going to jump all the way over here to no roots and put a little heading. Because I think we should be good to draw the next conclusion. What has to be the value of my discriminant so that when I do the red, I take the square root, I can't even get an answer. I think we should be quite comfortable to say that your discriminant has to be negative, so less than 0. I cannot calculate the square root of a negative value, so if b squared minus 4ac gives me a negative value, then that square root of it is undefined. I get no solutions. I get no roots. Okay. What's the column in between? Well, you should have some experience solving quadratic equations now, where you would have solved and you only got one root. And I want you to think about what would happen with my discriminant where I would only be able to get one answer. Okay, here's where my discussion earlier about which part of the quadratic formula creates two solutions can get a little iffy. If you focus in on the discriminant, then there has to be another part that comes along. Like really, for me to only get one answer, look up at my discriminant, I need to make the plus or the minus have no effect. Like I need to almost cancel out the plus or the minus, because if the plus or minus matters, then I get two answers. The only way I can get one answer is to make the plus or minus not matter. So I've got to think to myself, what value, when I add it or subtract it, doesn't change anything? And I'm hoping that we're quite comfortable to come in on 0. That if I add 0 to something or I subtract 0 from something, I stay the same thing. I don't change my value. So what in effect happens is I make the plus or minus have no consequence. Okay, for me to take the square root of something and get 0, that means what's underneath the square root must equal 0. Because the square root of 0 is 0. So the way that I can get one root is if what was underneath equals 0. It's not positive, it's not negative, but it is smack dab right at 0. Then the square root of 0 is 0, and adding or subtracting 0 has no effect. Okay, I am just going to get rid of everything with all those colors and everything that I put up at the beginning so we can just see a nice clean discriminant. We're focusing in on the blue. Okay, I want to talk a little bit about this mini chart because there can be some other ways that you hear about roots being described, and I want to make sure that you don't think we're missing something. Okay, first off, I want to jump down to the no roots part because there is another way that you can hear that, and you will often see it referred to as no real roots. The reason why the word real is in there is because you can get non-real roots. I know that sounds weird, but you can get imaginary roots. We just don't deal with them at all. That in your high school math courses, we do not deal with imaginary numbers anymore. And so I'm not going to make you write down no real roots to distinguish the fact that there are imaginary ones if you never work with them. So I am quite fine for you to state what you see in orange, no roots. Okay, let's jump back to the one root. There are other ways where you can see that. I'm going to avoid writing down real all the time because I think we've addressed the real component. But rather than seeing one root, you'll often see it described as one double root. And the reason why you would see a double root described is because you actually get two of the same root. So I'm going to just jot something down below. Let's just say I used quadratic formula, and when I went through and solved it, I got x equals, 5 plus or minus 0 over 2. Technically, what I get then is I get my 5 plus 0 over 2, or my 5 minus 0 over 2. I technically get two solutions. Let me sneak in my x equals. but I get 5/2 from the first one and 5/2 from the second one, that's just bad form to write. So I really get one root that shows up twice. A double root. I don't need you to distinguish that it shows up twice. There will be times where it's very important for us to know that it appears twice, especially when we get to the point of sketching functions. But that's not needed for us. So you are okay to stick with the orange and just state that there's one root. Okay, can we jump to the two roots then? There are times where you would now see two roots being written as 2, and again, I will skip over the real part. We've already addressed that. But you can sometimes see it described as 2 distinct roots. And the distinct just refers to different. That if you look under the one root heading, maybe if I write that as one double root or two equal roots, then I need to distinguish between two different roots. And therefore, I would say two distinct roots. Again, not needed. If you tell me two roots, I think your reader should be good to recognize that those are two different roots. Okay, what we have on the screen is super important. And what I really want you to take away with you, for us to have two roots means our discriminant must be positive. The plus or minus has to matter. For us to have one root, our discriminant has to equal 0. The plus or minus can't matter. And last one, for us to have no roots, then we cannot calculate the square root. So our discriminant has to be negative, must be less than 0. Okay, I'm hoping that that's not something that we need to memorize. So please do not spend your time trying to memorize a table. Rather, think about quadratic formula, which you should hopefully have in your back pocket, and use reasoning that we just talked about to justify whether your discriminant is positive, 0, or negative. Okay, what I want to do now is I want to spend some time working with the discriminant. So take a look at the screen you have now. The instruction for problem 2 is to determine the number of solutions for each one of those equations. Okay, we don't care what the solutions are, just how many of them do we get. And you'll see what I listed in red underneath. That is often referred to as the nature of the roots. If I was to ask you what is the nature of the roots, I would expect an answer of 2 roots, 1 root, or no roots. So let's take a look at A, and we'll walk through A together. If I asked you how many solutions do you get in that equation for A, or what is the nature of the roots, I would hope that you did not feel like you had to rely on subbing everything into quadratic formula, all over, whatever. That's too much detail. Since we don't care what the answers are, just how many of them, then what we can use is just the discriminant. So what we are going to use then is b squared minus 4ac. Let's examine what is the value of the discriminant. So if I sub everything in, then I'm going to get 5 squared minus 4 times 1 times negative 7. And I'm just going to stop there for a second because I'm hoping that you can see something. That as soon as my original equation was in standard form, so it had a positive leading coefficient, and you have a negative c value, then that negative 4 in your discriminant multiplied by your negative c value is going to create that add in between. And as soon as I'm taking a b squared value, squared, something that will always be positive, and I add more to it, then that's going to give me a positive value. That I'm just calculating 53 for confirmation and to tell my reader, but I should already be expecting that therefore there are 2 roots to that equation. So notice, I calculate my discriminant, but I can already see what I'm expecting. I'm going to get 2 answers to that. I don't care what they are. I just know that there's 2. Okay. I want to leave you now with B, and I think you should be comfortable to jump in with B. So try it on your own. Pause the video now. Okay, we're back. So same thing. Now, here's where I get a little more advanced. Because I take a look at my original and I notice I'm in standard form, my leading coefficient's positive, and I have a plus, a positive for my C value, well then that's telling me that there is the potential that when I use the discriminant, I could end up getting a negative value. Because when I calculate my b squared, that gives me a positive, but now my minus 4 times my a, which is positive, times my c, which is positive, means I'm going to be subtracting those 2 values. There is the potential for a negative. So I go through and I sub everything in to my discriminant. I get 20 squared, which is 400, minus 4 times 4, which is 16, times 25. Well, if I'm doing that without a calculator, then 4 25s is 100, and 4 times 4 is 16, so 4 times 100. Hey, I calculate 400 minus 400, there's my 0. So I calculated my discriminant. It's now my job to interpret it. What does a discriminant equaling 0 mean? Well, either we've memorized it from 5 minutes ago, or we look at that and say, what's underneath the square root symbol is 0. So the square root of 0 is 0. So if I add or subtract 0, I don't change anything. Therefore, I only have one solution or one root. Okay, hopefully that was pretty comfortable. What I want to do is just leave you with 2 more, and I want you to work your way through and comfortably, with confidence, tell me how many solutions. Tell me what's the nature of the roots. Okay, here they are. So there they are on your screen. I want you to take a moment to go through and just determine the number of solutions for both. Okay, then we'll come back and we'll check in. Okay, pause the video now. Okay, we're back. So if you've been following along a little bit, well then there's a positive and a positive. I have the potential for a negative. So when I calculate, I'm not going to write out my discriminant. I know that thing cold. I can calculate 11 squared, which is 121, minus 4 times 3 is 12, times 2 is 24. It's like I don't even care what the answer is. I can tell when I take 121 and I minus 24, I'm going to end up getting a positive value, therefore 2 roots. However, we do have to write some proof down. We do have to explain our reasoning. So when I do calculate that, I get 97. And because it's a positive value, I can make that statement on 2 roots. Okay, make sure you show me the value of the discriminant. It helps provide proof to your reader. Okay, we're taking a look at D. We've gone through and we've calculated D. And I would almost go positive and positive. Hey, I'm going to be subtracting. But now you start to look and you go like, look how tiny my B value is. When I square that, there's going to be no way that that's going to be bigger than 4AC. So I'm already anticipating when I calculate my b squared, and now I minus 4 times 11 times 2. Well, 4 times 2 is 8 times 11, 88 for everything that I said before. We need to make sure that we state that that is a negative 79. We then need to make sure that we interpret that and say, therefore, no roots. Okay, hopefully we matched up. Okay, what I want to do for the rest of the day is I want us to play around with 2 problems. It's really one problem, but it's going to have 2 parts. This would be some problem-solving stuff. This would be the sort of thing that says you have some knowledge with some things. Now what we want to do is we want to see how comfortable you are working with it. Can you tie some ideas together? Let's take a look at that problem. Okay, I want to give you a moment to read that problem. So pause the video. Okay, we're back. So for the equation 0 equals x squared plus kx minus 4k, you have to determine the value of k. So there is, and part A is asking for one solution. Okay, so what we need to notice when we break down the problem. Within that equation, x is your variable. You'll notice k is a coefficient on x in my middle term, and it's attached to my constant on at the end. So x is the variable, k is a missing value. What you have to do is you have to figure out what value of k would give that overall equation one solution. Okay, I want you to play with that. This is an opportunity to steal some problem-solving practice. So you give it a shot, struggle your way through. We'll see what we can come up with when we come back. Okay, pause the video now. Okay, we're back. So there are a number of ways to go through and deal with this problem, but probably the most direct way for us is to use our knowledge of what one solution means. So one solution tells me that if I solve that equation, I only get one answer. And then I can think back where either I have memorized how do I get my number of solutions, or I think back to quadratic formula, and it would say, okay, for that to give me one solution, I need to make the plus or minus have no effect. That means I need a 0. Okay, well, what we could do then is we could draw on our theory that says our discriminant has to equal 0. Okay, I just want to address one thing right off the top, that if you did not consider that in your solution, it doesn't mean that you had bad problem-solving strategies. Not at all. What it might mean is your brain just took you in a different direction. And I maybe want to note that the other way in which you only get one answer is if when you go to solve that, if it factors, for instance, then when it factors, it ends up giving you, and I'm just going to write in a little expression in the denominator, or sorry, the base of the power, but it would give you a perfect square. Notice that equation gives me one answer. Therefore, x equals b over a. So when we consider that, your brain, your strategy may have said, hey, but if that was a perfect square, then I only get one answer. You may even look and go, hey, my leading coefficient is just 1, so I don't even need that a out in front. X minus something squared. I think what can be difficult, though, is then you're trying to go, okay, I need 2 numbers that multiply to give 4k, and then add to give k, and those 2 numbers have to be the same thing because it's a perfect square, and that can become a little complex. So nothing wrong with that at all. That's good strategy, good thinking. You've tied some ideas together. I think it might just be a little difficult to execute right now. So I'm going to get rid of that strategy, but I really wanted to make sure that you didn't feel like that was leading you down a bad path if you considered that. That's actually really good. I think the most direct route, though, is to use our discriminant. Okay, why is that the case? Well, if you look back up in your equation, all I'm going to do is just get rid of the red and the green. And I'm going to do my best to get rid of it. If I end up erasing some of this, I'll just go, oh, I was erasing that, and oh, I'm erasing that, and I'm just going to slide back in everything that was missing. So I had a plus kx minus 4k. Okay, I want you to take a peek at that equation. And if I just highlighted that my a value is 1, my b value is k. Notice, my b value does not include an x. So make sure you're not including the variable. And my c value is this entire negative 4k. That I could sub those values or expressions into my discriminant. So what that would give me then is that my b value is k, so k squared, minus, now I'm just going to write this out so we can see it clearly. It's minus 4 times 1 times negative 4k. That's my discriminant you see in gold. The one solution tells me that's equal to 0. Please make sure that you are not tying any part of this equals 0 to this equals 0. No. The reason why my gold is equal 0 is because my discriminant equals 0 because of one solution. That one solution is why I have that equals 0. Okay. Look what you just built in gold. That's an equation with one variable in it. We can solve. So if I take my k squared, and now I simplify that. Well, a negative 4 times 1 times negative 4 is a positive 16. And I've got my k, and that equals 0. I just built a quadratic equation. And I can solve that. My primary method is to isolate. Well, I can't collect those easily. So my next method becomes factor. I have two terms, and the first thing I always look for is a common factor. And I notice I can factor out a k from both of those terms. When I do, that leaves me with another factor of k plus 16. And since that product equals 0, therefore the first factor equals 0, or the k plus 16 equals 0, which means I get a k value of negative 16. There we go. A k value of 0 or a k value of negative 16 gives me one solution. Now, if you wanted a bit of a check, this is always something you could do. Let's take both of those values, sub them in, and see what we get. So if I was to sub those in green, I'm going to sub in a k value of 0. That means I get x squared plus 0 times x, wipes that out, minus 4 times 0 wipes that. That green equation is my entire equation. So for me to solve, how do I get rid of a squared? I take a square root. Plus or minus the root of 0 is 0, and there's my one solution. That gives me a check. I know I'm good. Let's check the other one. So if I sub in a k value of negative 16, well, that's going to give me 0 equals x squared minus 16x. Now I've got 4 times 16, and it's a negative 4 times a negative 16. So that's going to give me a positive 64. Okay, I love that, because when I go to factor that, two numbers that multiply to give 64 and add to give negative 16 is negative 8 and negative 8. Now, I want to stop there for a second and notice you just came up with the solution for that other way you could have thought of the problem. Notice, if I have one solution, there has to be a perfect square. That's why I only get an answer of 8 and not something else. So, one answer only. There we go. Okay, I'm hoping that you like that solution. Look where it comes from. Most direct route. Use your discriminant. Use your discriminant to create another equation or create something else to work with. And then you can see where that takes you. Okay, I'm going to throw a doozy at you, and I mean it is a doozy. I want you to stumble your way through it. I'm telling you it's tough. It's not going to be easy. So you give it a shot, but this is like ultimate of problem solving. I want you to take a look at that part B problem, and you'll notice the entire setup is the same. The exact same equation, determine the value of k, but this time we're looking for 2 solutions. What value of k would give you 2 solutions? Okay, I want you to pause the video, and I really want you to try this one on your own. Okay? Pause it now. Okay, we're back. So I am going to shrink this thing down because there's a part to this problem that I think should be fairly straightforward. That is, there's a part where I would be a little concerned if you couldn't get to it. Then I tell you, like, hey, I thought that this one was like ultimate problem solving. It's not the beginning, it's where you go from there. So what am I talking about? Well, as soon as you see 2 solutions, I would hope that we then go, hey, my discriminant has to be positive. I have to be able to take the square root of a number and make the plus or minus matter. So I need a positive underneath that root sign. Therefore, what that gives me then is sub in your k, your b value, so k squared, minus 4 times a times c. So notice it's the same process as before, except we're greater than 0. So when you simplify that, you're going to get down to that exact same discriminant, but now greater than 0. I think if we got down to there, that is good. And that's what you should be happy with. If we got that, you're fine. Where this becomes difficult now is what you do next. I want to take you through something. There are a number of ways that you can solve this, but I want to highlight for you that this should be the first time you've really been working through an inequality, a greater than within your equation. That actually means that what you have there in gold is called an inequality. Sometimes you'll hear it referred to as an inequation. One side does not equal the other side. In fact, if you read this left to right, one side, the left side, is greater than the right side. So how do you go about solving that? That's what's difficult in this problem. So what I want to work through is how we could do it. And here's a little framework. I would hope that I would still have maybe some instinct to say, hey, why don't we factor this thing again? So why don't we take our k and factor it out? But you'll notice if I now write, therefore, k equals 0 or k equals negative 16, that's not correct. Those are the values that make that equal to 0, not greater than 0. So that statement is actually false, what I just wrote. My therefore, my conclusion is false. It's wrong. So how can we then denote, hey, I didn't really mean like those are solutions, but they're... In the future, you will hear those referred to as roots, which might be really confusing since those aren't the roots of the equation. What you can refer to those as are key numbers. Those will end up becoming really important values in our solution. Okay, what I want to do is I want to examine this green line. And I'm just going to box it in green because that's what we really want to focus in on. And we really want to focus in on what I just circled in red. Positives, greater than zeros. Okay, look on the left side of that greater than symbol. I have something times something. It's factored. Well, I could examine a case, and I'll call this one case 1. How do I make something times something give me a positive? Well, I think the most general situation would be to take a positive and multiply it by a positive. If I take a positive times a positive, I know that that equals a positive. So what I can do then is I could go through and I could say, I'm going to make, therefore, the first thing be positive, the first factor, k, and I'm going to make the second factor, k plus 16, also be positive. Notice, that is my positive times a positive. And if both of those things are true, then the product is positive. Well, notice, I already have a solution from the first one. K's got to be positive. And I now have a second inequality. Well, because that's a linear inequality, I can solve that as I would an equation. How do you get rid of a plus 16, u minus 16? So k has to be greater than negative 16. Well, what I just noticed then is the one statement that I could draw or write down that includes both of those is that k has to be greater than negative 16 and k has to be greater than 0. Okay, I want you to notice that that's a really poorly written statement because my two inequality symbols are pointed in opposite directions. That's not a good statement. That's an improper statement. So what I really want to think about then is what k values make both k is greater than 0 and greater than negative 16 and greater than negative 16 true. And I hope we're good if we can jump to k has to be greater than 0. If my k value is greater than 0, then both of those are true. K is greater than 0, obviously, duh, but also k must be greater than negative 16. Okay, that might be a little confusing for you. Don't worry, I told you this is complex. But now, let me jump into another case. If I slide that over to build my case number 2, you might see how I could also get a positive product. The other way I can get something times something to give me a positive is if I have a negative times a negative. That also gives me a positive. Well, the way that that would work, and I'm just going to slide this over, is if my first factor, k, was negative, and my second factor, k plus 16, was also negative. Okay, the first one's already solved. K has to be negative, and k has to be less than negative 16. Well, now I'm trying to imagine, okay, I have to make both of those work. K has to be less than 0, and k has to be less than negative 16. I'm hoping we come to k is less than negative 16 makes both of those true. Okay, from case 1, I now get k has to be greater than 0. From case 2, I get k has to be less than negative 16. Well, I can combine those now to create my final solution. If, and I'm going to put this in green, k is greater than 0 or k is less than negative 16, I get a positive discriminant. And that is my final solution. You give it a check, sub in a value less than negative 16, like negative 17, and you'll notice we get a positive discriminant. Or sub in a value greater than 0, like 1, and you'll notice we get a positive discriminant. Okay, maybe you can look at that full solution now and see why I say problem 3 is a doozy. Okay, that's like above the level of our course. But I'm hoping that us going through the solution together, you can see how we could determine that. Okay, I threw a lot of stuff at you today. The main focus, being able to tell the number of solutions within an equation, and let's focus in on question 3A. Can you use what you know about the number of solutions to determine something about an equation? To go backwards. Okay, your job now, jump in and get some practice. Best of luck.